Hi, Alan Stratton from As Wood Turns. There's a bit of history for this project. First and foremost, a long time ago, I did some marquetry work. What's marquetry? Well, it's the process of taking thin veneers and cutting them into a picture, gluing them onto a substrate, and having a nice picture out of it. A relative of that is called parquetry with a P, and which you're using thicker wood and solid wood to create a picture. Substrate really doesn't matter, you want 3D depth in it. So when I came home from SWAT, where John did a good demonstration with using the vacuum chuck on the lathe to do an inlay project, I made this one successfully, but without using a vacuum chuck. But as I did it, I realized that I was probably working still too hard, and I wanted to do it with the drill press instead of the lathe for drilling. I thought there would be advantages to that, and so the other advantage being is that this looks a lot like marquetry. So in this case, this is inlay using the drill press for drilling, to the lathe for final turning, and I did achieve a profile here on the edge, so this is definitely not marquetry. So we'll go through that. I think it turned out nicely. I hope you do also. If you have other ways of doing this, I'd be glad to hear what they are and other thoughts on this matter. So let's do it.
I am starting with a printed pattern designed on my computer. Any drawing software will do. I glued this pattern to a square of walnut about 1 inch thick. The glue is regular type bond instead of rubber cement. Since I figured it will need sanding, I did not want rubber cement to gum up. Maybe not a big deal, but anyway. My pattern has crosshairs at the center of each circle and a background of concentric circles with large crosshairs. These large marks will come in very handy later. After center punching each circle, I have a 3-inch Forstner bit in the drill press. I am not going to worry about the drill's center point. Others have suggested that I grind off that point. However, I need it for centering the bit in the drill press. I will drill entirely through the wood. I have 3D printed flat circles in a range of sizes to serve as templates. I saw this in John's demonstration and find it very handy. However, I confess that I used the template to get close, then switched over to my metal lathe for more precision. Now for a trip to the glue station to epoxy the inlay wood. I prefer 30-minute epoxy over wood glue since epoxy is much better at gap filling than wood glue. I also prefer epoxy over CA glue since it is supposed to have a much longer life. Why not 5-minute epoxy? Well, I don't like tight deadlines. By the way, I also marked grain direction to keep me straight. Now for the next set of inlays, 1.5 inch diameter. Back to the drill press. This is easier than drilling on the lathe. Since there are 4 identical inserts, I glued up a stack with paper joints so I could cut them all at once. This will be nice to do all these at once, but paper joints come apart, and that is exactly what I do not want right now. So I re-glued them, but let the joints dry overnight, and then was extremely careful at the metal lathe. Now for the third set, 1 inch diameter, and glue them in the same way as the previous one. I decided to have a center inlay to the larger maple disc. Back to the drill press. I learned my lesson with the paper joints. Fortunately, I only need one and the template works great. More epoxy to fasten it all together again. The preparation inlay work is complete. Now a tricky part. I need to center my project to mount it to the lathe. After extending the crosshairs back to the center, I drilled a small hole in the center. I need to flatten the backside at the drum center. However, the top side is an uneven mess. With some hot melt glue, I fastened a couple of scrap plywood pieces to the top side. With these shims, I easily flattened the backside at the drum center. With that preparation, I could epoxy on a piece of maple veneer and another 1/4 inch piece thick of solid walnut. Then clean up the top side again at the drum sander. It appears that one of my inserts is below the surface. That is not a problem since I will be hollowing this side. Using that small hole in the center, I drew a circle at the same diameter as the faceplate I plan to use. Double stick tape secures the faceplate, but I have too much work into this to trust tape completely. Hot melt glue provides more insurance. I'm finally ready to head to the lathe. First task at the lathe is to trim the perimeter. Then lay out marks sized for the center mortise. This is not a tray, so I'm using a set of medium-sized jaws for a smaller mortise. This is mostly done with a box scraper, but fine-tuned with my skew. As is, the mortise is about 1/4 inch deep, exposing the maple veneer. However, in the next step, then I will taper from the surface intended to be the resting surface down to the mortise, leaving the mortise less than 1/8 of an inch deep. Next, cut a cove for the ogee curve, followed by a bead to blend it into the bottom and to the taper. Then test the chuck fit and fine-tune the fit and the surface. Then I sand this side through all the grits. Now apply wipe-on poly while still mounted to the lathe. With the bottom side all finished, I can reverse the wood using that mortise with a padded live center for insurance. This now is standard hollowing with my large bowl gouge. The critical concern now is to not cut through to the maple veneer. While not a funnel, that would totally spoil my inlay platter. My paranoia shows with the number of times I stop and check the thickness. Finally, after sanding, apply more wipe-on poly. This completes my inlay project using the drill press for drilling instead of the lathe. With the process adjustments, it worked great. I had to integrate the best features of several tools. I wanted the inlay to show depth with the hollow profile. It does. So I like this inlay platter. What inlay project would you make? And what process adjustments would you anticipate? Please give this video a thumbs up and subscribe to my website as well as on YouTube. Please spread the word by telling your friends about my weekly videos. I also appreciate your comments and questions, but please wear your full face shield whenever the lathe is running. I hate to nag, but are you wearing yours at the lathe?